In this tutorial, we're going to look at using crystal graph convolutional neural networks to predict material properties associated with CIF files. So to do this, we're pretty much just going to use the code as is. There's just a little bit of data restructuring that we're going to have to do. I'll show you how the data needs to be structured specifically to train and to validate given one of these networks in this code. So to get this code, I'll put the link in the description, but you can go ahead and navigate over here to get this GitHub. Now if you have Git installed on your computer and if you're comfortable with it, you can always clone this repository. What I'm going to quickly do is download the zip file. I'm going to put it into this empty folder cgcnn. So we'll grab this master zip and I'll go ahead and extract this really fast. So I'm going to just extract this here and we'll get our cgcnn master directory. And in here we can go ahead and access the stuff associated with cgcnn. Now cgcnn is based on neural networks. It uses PyTorch, sklearn, and pymatgen. Now these packages, you'll have to install these on your computer. I'm not going to cover how to do that. I will say if you've never used neural networks before, it's worth looking up how to install PyTorch. And if you have a GPU on your computer, it's going to drastically improve performance. It's going to make things a lot faster to do training and inference. So you'll probably want CUDA and CUDIN. Again, I don't really want to talk about those things. It's a sort of difficult thing to handle and to take care of, but if you can figure that out on your own, the rest of this should be pretty easy. If you haven't used neural networks before, go ahead and read through these prerequisites. And again, you're going to want to look at getting CUDA and CUDIN on your computer. I believe if you're on Windows, you can use TensorFlow. So you can do something like pip install TensorFlow GPU. And this will install the appropriate CUDA and CUDIN for your graphics card. But it can be sort of a tricky thing, and I don't want to worry too much about that on my end. Good luck with that. Now, assuming you have that or you don't want to use a GPU, you can go ahead and use pip to install these and sort of move on. And then the question becomes, okay, how do I format my data so I can make a prediction? How do I make a prediction? And once I have a trained model, or sorry, how do I format my data so I can train? And once I have a trained model, how do I make a prediction using those fixed network weights? So here they show us how to format the data. So we have our directory, our root directory for where the data is located. We have an ID prop file, we have an atom init file, and then we have the CIF information. So let's go ahead and make this a little more concrete. What they're talking about would essentially be going into this data folder and clicking on one of these where we have our CIF files themselves. Go ahead and open one of these. We have this idprops.csv, which is a list of the CIF files and their associated properties with no headers. And then over here we have atom init. And this represents atomic properties associated with the atomic numbers 1 through, I think it's like atomic numbers up to 100 or something. Okay, so if your data is in a folder similar to this with these CIF files, this atom init, and this ID prop, just there you're already ready to train a model. So if we want to do that, we can go ahead and come here to train a cgcnn model. Now the first time we'll go ahead and train on something trivial, just this this sample data they have here. And if you saw the targets, they're not actually meaningful targets. They're CIF files with values, I think, like 1 through 10. So these aren't real targets, but I'll show you some data from the AFlow project that does have actual target values we can predict on. But in order to make a prediction, let's talk about this. So for train a cgcnn model, they have these commands you can use to train a model. Now I'm interested in this one. So we're going to ask it to use Python to run the main file, and we're going to give the train ratio, the validation ratio, and the test ratio. And then we're going to tell it the location of the data we want to train off of. And so again, that's one of these folders that has the ID prop, the atom init, and the CIF files. So in our case, they're saying go to the data folder, go to sample regression, and train using the stuff in here. Okay, so to run this, we want to input this either into the terminal or into the command prompt. Or in my case, I'm just going to go ahead and use Shift and right-click and open up my PowerShell here. So once I have my PowerShell open, I can go ahead and copy this text, and as is, because I opened my PowerShell in the correct directory. So you'll notice my PowerShell is in F, Sparks Groups, Presentation Resources, Tutorials, cgcnn, cgcnn Master, which is this location here. I can go ahead and just paste in that code. So now I'm just going to hit enter and run this. And as this is sort of going, we'll talk about the next set of data. So I'll leave this open to run. Actually, that was so fast I couldn't even start talking because there's only 10 CIF files in there. And so this was what training looks like. It trains through a training set, and then the validation set, and then this final is the test set, and it evaluates how well the model did on the test set. Now these results are sort of meaningless because our target and the CIF files are meaningless, but let's grab something more meaningful. So if we go out down to this tutorials folder, and you of course won't have access to this, I pulled this from the AFlow repository, and if you go ahead and email me, I might be able to send you a folder that has this, though I assume you're using this for yourself. This data is sort of trivial, easy to get. I don't know if there's a lot of use for it, but what I have is 500 and about 61 CIF files from AFlow. It's 561 CIF files, and then those CIF files, I also have their associated bulk modulus values. So I don't have that header, and I have the CIF file, or the name of the CIF file, and I have the target associated with it. In this case, bulk modulus, and I should have that same number, 561. Perfect. Okay, so I'm going to take this folder, and I'm just going to go ahead and copy it into this data folder in the in cgcnn master. So data, so we used sample regression for this previous run. So now I'm going to go ahead and paste in AEL bulk modulus VRH. Okay, so now instead of running, so let's kind of go through this code one more time. Let's just go ahead and do that. Okay, so instead of running Python main.py, train ratio, validation ratio, test ratio, on the folder data / sample regression, a little bit bigger. What we're going to do is we're going to get rid of sample regression. We're going to do data / and we'll say, okay, go into AEL bulk modulus VRH. Now before I do that, if we go into this folder, I haven't included the atom init file. So very quickly what I'm going to do is I'm going to copy that from either of these folders and paste it into this folder I want to do my learning from now. So now if we look at it, if we go to the different types of files I have the ID prop CSV, the atom init JSON, and then the different CIFs associated with the target I'm trying to learn. So now I'm going to just go ahead and hit enter here. I've told it to run the main file with these ratios on this specific set of data, which is this AFlow bulk modulus data. And now it's going to initialize training. So it has to convert all of these CIF files into graphs, so it's going to take a lot longer before it gets to this training step. And while it's doing that, we can go back over to the, sorry about that. So while it's doing this, we can go back over to their repository. I'm just going to put this on the side so we can keep an eye on it. And once a training run has happened, what we're going to get is these three files. So we're going to get the best model, we're going to get a checkpoint, and then we're going to get test results. So we're going to use this best model, and we're going to take it and we're going to use that to generate our predictions. So in our case, how they're formatting this is they're saying, instead of running main.py, we do Python in here, we do predict.py, and then we give it the location of the network weights we want to predict using, and then we give it the location of the data we want to predict on. So in this case, what they're saying is they're using Python to predict the pre-trained formation energy weights they've already computed for us on these sample regression data points. So what we could do is if we had a batch of CIF files we want to predict a bulk modulus for, on the training that was generated, or in the training loop, what was generated was this modelsbest.path.tar. We could replace this line right here with modelsbest.path.tar. In fact, let me go ahead and show you what I mean here. And then we could replace this with the data we were actually interested in. So let's go to this. go ahead and make a new file here. So instead of predicting here, go ahead and predict on models or model best .pth .tar. So we're telling it to look at these model weights, and then we could tell it to predict on this data. So in our case, we have AEL bulk modulus VRH, so we could have like test AEL bulk modulus VRH. And if we were to run this, just how we ran this over here, what we would get out is predictions on, instead of the CIF files here, in the new folder. So if we made this test AEL bulk modulus. Now if we're going to run a prediction on this, we would also need to include these types of files. So in our case, I paste them into here. And then if my CIF files have a different name, I would have to change the name of the CIF files. And because we're going to be predicting these values, it doesn't matter what's in this column, but it has to have something in this column. So I could have test CIF 1, I could have test CIF 2, etc., etc., and then I could just put gibberish in these columns. And then if I had a CIF file for test CIF 1 and a CIF file for test CIF 2 in this folder, when I ran it, it would generate predictions for these CIF files. So this will take a while to train, and I don't think you want to wait for that. But what I'll do is I'll finish training this, and then I'll continue. Nope. If this doesn't get you far enough, tough luck. You can email me directly, and I'll have my email in the description. Good luck. Hopefully that helps you get started. It's really not super hard if you can format the data correctly.